I would like to invite you to explore a topic that sits at the intersection of nutrition, inflammation, and long-term human health, a topic that is rapidly gaining attention in scientific and medical communities worldwide. We are going to discuss a growing body of research suggesting that vitamin B12, a nutrient traditionally associated with nerve health and red blood cell production, may play a far more influential role in our overall well-being than previously understood. Specifically, we will examine how vitamin B12 appears to be deeply connected to chronic inflammation, a biological process now recognized as one of the central drivers of many modern diseases. This emerging insight has the potential to reshape how we approach disease prevention, nutritional guidance, and public health strategies. To appreciate why this research matters, we must first understand inflammation itself. Inflammation is a natural and essential biological response. It is the body's defense mechanism against injury, infection, and harmful stimuli. When you cut your finger or catch a virus, your immune system releases inflammatory signals that increase blood flow, recruit immune cells, and initiate repair. This process is both necessary and life-saving. However, inflammation becomes dangerous when it does not shut off. Chronic low-grade inflammation can persist silently for years or even decades. Unlike acute inflammation, which causes visible redness or swelling, chronic inflammation often goes unnoticed, yet its effects can be devastating. It has been strongly linked to cardiovascular disease, type 2 diabetes, neurodegenerative disorders such as Alzheimer's disease, autoimmune conditions, certain cancers, and even depression. In essence, chronic inflammation is like a fire that never fully goes out, slowly damaging tissues, organs, and metabolic systems over time. The question modern science continues to ask is this: what factors fuel this persistent inflammation, and how can we control them? Vitamin B12, also known as cobalamin, is an essential nutrient that the human body cannot produce on its own. It must be obtained through diet, primarily from animal-based foods such as meat, fish, eggs, and dairy products, or through supplementation. Traditionally, vitamin B12 has been recognized for three main roles: supporting the production of red blood cells, maintaining healthy nerve function, and supporting DNA synthesis and cell metabolism. Deficiency in vitamin B12 can lead to anemia, fatigue, weakness, memory problems, numbness or tingling in the hands and feet, and in severe cases, irreversible neurological damage. What has not been fully appreciated until recently is the broader systemic role vitamin B12 may play, particularly in regulating inflammation. A recently published study in the Journal of the Science of Food and Agriculture has provided compelling new evidence linking vitamin B12 levels with markers of chronic inflammation. The researchers analyzed data from the PREDIMED study, a large and well-known clinical trial conducted in Spain. Originally designed to evaluate the health benefits of the Mediterranean diet, the PREDIMED study followed thousands of participants over several years, collecting extensive dietary, biochemical, and health data. Using this rich data set, scientists focused on two key inflammatory biomarkers found in the blood: interleukin-6, IL-6, and C-reactive protein, CRP. Both of these markers are widely used in clinical and research settings to assess inflammation. Elevated levels of IL-6 and CRP are strongly associated with cardiovascular disease, metabolic disorders, and premature aging. What the researchers discovered was striking. Participants with higher blood levels of vitamin B12 consistently showed lower levels of both IL-6 and CRP. In contrast, those with lower B12 levels tended to have higher inflammatory markers. This association remained significant even after accounting for factors such as age, sex, body weight, and dietary patterns. In other words, the relationship between vitamin B12 and inflammation was not coincidental. It appeared to be biologically meaningful. The implications of this discovery are far-reaching. First, it reinforces the idea that micronutrients do far more than simply prevent deficiency diseases. Vitamin B12 is not just about avoiding anemia or nerve damage. It may play a critical role in regulating the immune system and controlling inflammatory responses throughout the body. Second, it provides a potential explanation for why individuals with low B12 levels often experience a range of seemingly unrelated health issues: fatigue, cognitive decline, cardiovascular problems, and metabolic disorders. Chronic inflammation could be the missing link connecting these symptoms. Third, it highlights a potentially modifiable risk factor for chronic disease. Unlike genetics or aging, vitamin B12 status can often be improved through diet, supplementation, or medical intervention. To fully appreciate the importance of this finding, it helps to understand how inflammation contributes to disease development. Chronic inflammation damages blood vessels, making them more prone to plaque buildup and atherosclerosis. This process increases the risk of heart attacks and strokes. In the brain, inflammation disrupts neural communication and accelerates neurodegeneration, contributing to conditions such as Alzheimer's disease and other forms of dementia. In metabolic tissues, inflammation interferes with insulin signaling, leading to insulin resistance and type 2 diabetes. Even in cancer, inflammation creates an environment that promotes tumor growth, DNA damage, and metastasis. Thus, anything that can safely and effectively reduce chronic inflammation has the potential to impact a wide range of health outcomes. One of the most concerning aspects of this research is how common vitamin B12 deficiency actually is. Older adults are particularly at risk because the body's ability to absorb vitamin B12 declines with age. This is often due to reduced stomach acid production or conditions such as atrophic gastritis. People who follow vegetarian or vegan diets may also be at higher risk, as plant-based foods contain little to no natural vitamin B12. Certain medications, including proton pump inhibitors and metformin, can interfere with B12 absorption as well. As a result, many individuals may have suboptimal B12 levels without realizing it. The symptoms can be subtle at first: fatigue, mild cognitive issues, mood changes, and are often attributed to stress or aging. If inflammation is indeed linked to low B12 levels, then undiagnosed deficiency could quietly contribute to long-term health decline. One of the most compelling aspects of this research is its relevance to aging populations. As people age, chronic inflammation tends to increase, a phenomenon sometimes referred to as inflammaging. This low-grade, persistent inflammation is thought to be a key driver of age-related diseases and functional decline. If vitamin B12 plays a role in regulating inflammation, then maintaining adequate vitamin B12 levels could become a simple yet powerful strategy to support healthy aging. This has important implications for public health policy, clinical screening, and nutritional guidelines. Routine monitoring of vitamin B12 levels, particularly in older adults or those with risk factors, could help identify individuals at risk before irreversible damage occurs. Moreover, targeted dietary recommendations or supplementation programs could help reduce healthcare costs by preventing inflammation-related diseases rather than merely treating them after they develop. While the findings are promising, the researchers are careful to emphasize that more work is needed. Several important questions remain. Do the anti-inflammatory effects of vitamin B12 differ between men and women? How does vitamin B12 interact with other nutrients involved in inflammation, such as folate, vitamin B6, and omega-3 fatty acids? Are certain populations more responsive to B12 supplementation than others? How does vitamin B12 influence inflammation in specific conditions such as obesity, autoimmune diseases, or irritable bowel syndrome? What are the long-term effects of improving B12 status on disease progression and longevity? Another area of interest is understanding why vitamin B12 absorption declines with age and how this process might be slowed or reversed. Researchers are also exploring differences between humans and animal models to better understand the biological mechanisms involved. While scientists continue to investigate the finer details, the practical message is already clear. Maintaining adequate vitamin B12 levels is an important component of overall health. This does not mean that vitamin B12 is a miracle cure or a substitute for a balanced lifestyle. However, it does suggest that paying attention to micronutrient status is an essential part of disease prevention. For individuals, this may involve consuming a balanced diet that includes reliable sources of vitamin B12, being aware of symptoms associated with deficiency, discussing B12 testing with healthcare providers, especially for older adults or those with risk factors, and considering supplementation when dietary intake or absorption is insufficient.
For healthcare systems, it highlights the importance of preventative care and early nutritional assessment. In closing, the emerging connection between vitamin B12 and chronic inflammation represents an important step forward in our understanding of human health.